So before we jump into our current webinar, let me take a pause and refer back to the previous one, because there we talked about AI and all about AI, and we made some claims that there is no AI without APIs and no APIs without API management. And we shared some blueprints there about AI runtime and API runtime. You can watch it all back. But if you take a peek at the blueprints, you will see that there is this OpenTelemetry guide there. And it was there all the time in all blueprints, but we haven't touched based on observability in detail in that webinar. So basically, we will continue this one, and now we will entirely focus on this domain. So let's start. To me, when I think of observability, it's like a spectrum. On one end, there is you observe nothing and just fly blind. And on the other end, you try to collect everything possible. And I can tell that I was at the Black Friday outage in a previous company I worked for, and we had a huge traffic spike because people started to come in. And in e-commerce, an outage is quite painful. And we had a downtime for 2 hours during peak traffic. And this entirely related to observability, because we thought that we have good observability in place. We collected CPU and memory metrics and so on, but it did not allow us real insights. What is the problem? And once you are burned, you start to collect everything possible because you were burned, of course, and you want to avoid that. And here the problem is that doing this without any strategy or goal means you will burn again. Now, maybe at a different place, maybe not during an outage, but by costs, or during an outage, because you will have a hard time to find the real insights during all the noise. And what if I would tell that there is a smarter way? You could optimize the signal to noise ratio. And noise means the irrelevant data, and the signal is the meaningful data, what you really want to observe. And you could cut the bill as well while doing so, and use any tool that you already know or like, all without vendor locking. And ultimately, the goal is to see requests end-to-end from client to all the way to the backend, and also spread through microservices, and pinpoint the problem source quickly. And also, being a former CTO, I resonate a lot with reducing mean time to recover. This is one of the key metrics you want to keep very quick to recover, and also keeping the SLAs in a good shape. But you have to ask yourself the question, are you stuck with an outdated, rigid, or as you see here, insert any adjective observability tool? And here, what you could insert into the placeholder might be something that you could like beep out as in the movie, or anything like inflexible, or bad user experience, or costly. But you might say, I cannot switch. I'm already logged in with my observability tool. We have a setup, and I cannot change the status quo. I cannot risk. But with Traefik and OpenTelemetry, you can experiment as you like without breaking your existing integration. Let's say you want to try, instead of using Prometheus, you want to try Dash0. You can experiment with that, no problem. Instead of switching tools from one to another and then just go with one, you can ship your data to both for some time, experiment with it, and only keep the better one. And how it's possible is because you can configure different signals to go to different places with Traefik, and also the OpenTelemetry collector allows you to ship to multiple endpoints where you can build and trust and experiment and start to see results, actual results. But to harness all these benefits of observability, one thing to keep in mind is to keep your traffic updated. Until version 2, there was open tracing support in Traefik, which is now deprecated, not in Traefik, but I mean industry-wide. And also Traefik V2 is now just receiving patches, so you should switch to the V3 version. And I had a conversation about months ago with a customer who whom I had a discussion how they can get the most out of observability. And basically the conclusion was to upgrade. They were still on V2. And in V3, we switched to OpenTelemetry that we see as the successor and the future of observability. And we always try to focus on good user experience. And this is where we saw also OpenTelemetry as where the industry moves. And it unlocks huge potentials. And I know that Michele is a good storyteller. So maybe can you fill us in how OpenTelemetry became the de facto standard in observability?
Yeah, it's actually a pretty fascinating story. You were mentioning open tracing. Open tracing is was a community and a set of open source implementations and standards that effectively were something that Google open sourced from Dapper. Dapper is effectively the progenitor of all modern distributed tracing systems. At the same time, Google had also created a different standard for doing not only traces, but also metrics, and its name was Open Census. And in 2019, seeing the competition between these two open standards are actually harmful for the community, the two communities came together, and out of that moment of love, came out OpenTelemetry. Emmanuel is perfectly correct in saying that OpenTelemetry is the future. The thing is, OpenTelemetry is also the present. OpenTelemetry is the second largest project in the Cloud Native Computing Foundation, and in some metrics, it's even bigger than Kubernetes. Parts of it, large parts of it, are very production grade and used in production by most of the companies that you've heard of. There are some parts that are still evolving. For example, distributed continuous profiling is something that is not stable yet. But ultimately, if you're monitoring anything in a backend and you need the classic logs, metrics, and traces, OpenTelemetry is a safe bet. It provides you ways of avoiding some of the most dangerous vendor lock-ins. The fact that it costs you a lot of effort to actually collect telemetry with different technology. If any of you has had the questionable pleasure of having to switch observability vendors, and all of a sudden you are ripping out half of your infrastructure and replacing with another one later, you know what I'm talking about. And OpenTelemetry solves that. The OpenTelemetry collector, which is one of the centerpieces of OpenTelemetry, is effectively the last observability agent that you may have to install and learn in your life.
Yeah, thank you, Michele. And you mentioned that community took a big part in it. And actually, we met during KubeCon EU last time. And this is where we started the conversation, and you audited our OpenTelemetry implementation in Traefik. And what happened is that we drafted an action plan for improvements. And in v3.5, the latest minor of Traefik, we brought some of those enhancements. And here, just to name a few, we reduce the span count outputted by Traefik. So now, instead of for one request generating 18 or 20 spans, now only one client and one server span is there. So basically, with Dash0, who pricing model is based on ingested span count, this makes like a 10-fold decrease of costs. And we also added Kubernetes attributes allowing enhanced event correlation with other events inside the Kubernetes cluster. And we now follow better the semantic conventions of observability, OpenTelemetry. So now you can use out-of-the-box dashboard. And our work is not finished here. There is still room for improvement. And one additional item that just came in the latest patch version of Traefik is the log body now filled with the common log format used by Nginx. And this enhances compatibility with the Nginx based ecosystem. And it might be a surprise to some, or it might be news for you if you haven't heard already. But during that KubeCon, it was announced that Ingress Nginx in Kubernetes is approaching its end of life. Today, it just receives security updates, patches, but no more new features are added. And this is when we took an action to provide Traefik as a drop-in replacement for Ingress Nginx. So in Kubernetes, Traefik can now read the Ingress Nginx annotations and also outputs the same log body format. So it's a drop-in replacement. But talking about updates and upgrades, you can do it also on a different axis. You start probably with the open source proxy, the free version, which is a very capable Ingress controller. But also you can move for API gateway, for targeting enterprise advanced features that are not in the open source version. And it's just a simple Helm upgrade, 30 seconds to get the other version with the license. And then when you have everything in place, basically another license unlock, but no more changes to your infra, and you reach more API governance with API management. But what does this mean for observability? Because now you can see a lot of features here on this slide, but what it means for the current topic. And one key point is that the upgrades during the different layers, different levels, is seamless, additive. It means that every configuration stays the same and you just get more and more features. So what do you get? In proxy, you get the data flow metrics, what we call data flow metrics. This allows you to observe the data flows, where it goes. And one thing you must monitor well is the Ingress controller. This is the central piece, the gateway where data enters and also leaves your infrastructure. You can discover bottlenecks and request delays, failures, and so on. And as you move to API gateway, this stays, and then plus additional metrics unlocked, now targeting specifically AI, and also we have something else in the queue. Stay tuned for some announcements in a couple of weeks. So here you get to understand what are your most used AI endpoints, what new feature, what the performance impact if you add the new feature, and so on. And again, if you upgrade to API management, the biggest addition is the business-oriented metrics. This is where you will see how you can monetize your APIs, who is your biggest paying customer, correlate some patterns with your revenue, and so on. But this is all still very high level. You might ask how to configure all of this. And this is why I include here a zero to hero journey, how you can configure this and get the most out of your traffic. And one key point is that when you start with a blank configuration, you will still get some observability. Prometheus endpoint is enabled by default, and you will see some logs. But this is not where you want to be. You want to go further. with just a few lines, you can enable metrics which tell you if there is a problem very easily. You will see it on dashboards, or you can put some alerts in place. Tracing, where you will see exactly where the problem lies, and logs, which can tell you why this happened in the first place. And one thing, logs and access logs are differentiated in Traefik. Log is the actual gateway log, the gateway processes logs, and access log is the client requests, the logs which hit the gateway. And you can also see that today in Traefik, logs are behind the experimental feature flag. It doesn't mean that you cannot use it in production. It just means that Traefik is Go-based, and the Go SDK in OpenTelemetry also has a life cycle. And today it's when we added it during development phase, and this is allows us, if any breaking change happens upstream libraries wise, we can propagate it downstream without any problem on the breaking change, because it's called experimental feature. But still, you can totally use it. But this is just the start. You point to your OpenTelemetry collector, and what you want to eventually provide some context, because telemetry without context is only data. I stole this tagline from Michele. This is one of his favorite quotes. And one thing you can customize is the service name. Out of the box, it's just called Traefik. But if you have different environments, definitely define where this traffic lives or what it's capable of. But context can be also enhanced further. Better resource attributes lead to better insights. You can add additional labels. Or if you have deployment through Ansible, like you are running on bare metal and so on, you can inject some variables, or you can do so with Helm as well. Add some information about the functionality, some business unit, and so on, to even enrich your observability further. Or you can generate less data, like you can turn down debug logging to just see warnings and so on. And there are many more options in the documentation. This is just like a couple of things I pointed out. And still, we are using OpenTelemetry collector and HTTP-based transfer. You can see under OTLP, there is the HTTP block. But you can switch also to gRPC. And if you just want to quickly experiment with, for example, Dash0, you can point directly to Dash0 without installing the OpenTelemetry collector. One thing to keep in mind is that OpenTelemetry collector is very much advised to have it in production, and you should have it. But really, for quick experimentation, you can just point it directly to anywhere you like. And you can add additional headers. You can fine-tune what your API key allows for access. Dash0 has settings that, for example, allow only ingestion permission and so on. So without further ado, I think let's see something on your side, Michele.
Wait a second. Before we go there, Andreas has a question, which is a very interesting one. It's about migrating to the new awesome setup. And he asks, can OTLP logs be activated while using the existing logging mechanisms in parallel to allow for stepwise migration and testing?
So today we have an open issue for that. When you configure OTLP, I think the standard error output is now just gone. So you see a blank screen if you query the logs. But we will want to fix that, and we will fix that.
Yeah, it's generally a great idea to keep kubectl logs working in parallel.
Exactly. And this is something for the standard output, but for the structured output, like JSON format or the command line format, I'm not sure that this is disappearing, but I know that we have an open issue to fix this bug.
All right, then shall we have some fun?
Yes, let's see some demo.
Let's see some demo. Just a second to figure out again how am I supposed to do sharing in Zoom. Every time is interesting. So folks, what you see on screen is Dash0. It's the product that I'm building with the rest of my company, and I am head of product, which means fundamentally two things. If there's something that you do not like, it's my fault. And I also get to explain you the principles by which we build Dash0 and the experience as I demo you the system. I will first show you how to troubleshoot the most complex use case of the OpenTelemetry demo application in 2 seconds or less. And then I will go and have a look at the observability of Traefik itself, because Emmanuel and the others have done a pretty good job, I have to say. Now, the first thing that you see when looking at Dash0 is a very peculiar usage of color. I always say to my designers that the user attention is a precious and valuable commodity, and it must be directed to what does not work. The golden rule in Dash0 is that red is bad, yellow is not great, and gray is okay, and you can ignore it. So we have two red things on screen, and we're going to look first at one and then the other. Let's start from the product catalog service. And in order for you to appreciate the step change of the 2 seconds resolution that I'm going to show you, I will first start by demoing the observability troubleshooting flows that you may be familiar with from other tools that you have used. In this particular case, just by virtue of opening, clicking on the node, on the service. This, by the way, is a service map where each of the components of the OpenTelemetry application is represented as a box. If you scale out the application to have multiple pods as it runs on Kubernetes, they still remain one service. They're just backed by multiple pods. In this case, 3 of them. I could click on viewing alerting and show you what the solution is, but there is no fun in that. So instead, I'm going to show you how to troubleshoot this at 3 a.m. in the morning. One click, and I'm in the telemetry tab. This gives me an overview of all the telemetry that I know it is associated with this service. And this is one of those associations that you can do with the resource attribute facilities, for example, that Traefik is showing you. This outlier map is designed to give you an idea of all the things that are bad. So remember, red is bad, or that are slow. Slow is high. Here there is a nice cluster of errors. One click, and I am into a higher resolution of the same information. By the way, we are looking at 30 minutes of data, which is boring. Let's do something a bit funnier. 6 hours. Now you see that the data is spread in more places. I can select by interacting with the charts. All the charts in Dash0 are interactive because you should be able to just point at it and say, hey, what's that? And you see also that just by following the color, you figure out what's going on. These are the spans in the heat map, and with like every observability solution, good at APM, one click and you're in the trace. This is a distributed trace, is one of the things where Traefik, as you see here, is contributing by emitting OpenTelemetry spans. And you also will see that it's also correlated with the logs. One click, and I can go and see this particular log in the logging tab. This, for example, is a Traefik access log. But then again, this is distributed tracing. It's a single trace. We are looking at effectively one leaf in the forest. Sure, this API has failed and the error propagated upwards, but is it an isolated case or is there a pattern to that? So how would you go about troubleshooting it with other tools? You would start filtering and grouping, hoping to land on a pattern. And Dash0 does support you in that if you want. For example, as you see, the moment that you want to add more filters to reduce the amount of information on screen, we do not only give you all the options, but we also tell you how correlated they are with the errors that occur and how often they actually occur. In particular, you see here that all the errors are clustered around this product catalog service get product API. It's already one step forward. If I clicked on this and started grouping, I would eventually get to the answer. But this is too slow. Let me show you the really fast way. And one, and done. This is Dash0 triage. It's effectively mathematic, run at scale to tell you what are the commonalities between the errors and the differences with the stuff that did not fail. Dash0 now went live, over 6 million spans in the blink of an eye. None of this is materialized, none of this is recorded. This is just your experience in using Dash0. And it tells me that all the errors are concentrated in this particular attribute. So there is something going on with the application product ID, which is making it fail. This is something that if it's only one product ID, you may figure it out after a bit, looking one trace at a time. When I actually checked what happened if I increased the amount of failing product IDs to above 7, which is the amount of, it's roughly the very short-term memory of humans on average. So the moment that it's above that, then people stop noticing that it's always the same product IDs showing up. But triage does not care. Triage is statistics. You press the button, it tells you what the problem is. Now, triage is cool, and distributed tracing is very, very structured data. Do you think we can have the same experience with completely unstructured logs? Now, we are faced with two options. One, I'm mad and I'm challenging you for something my product doesn't do, or actually it's going to work. Let's figure it out. I'm going to switch to the login tab. Here's where we see the logs. And I'm going to select, again, my product catalog service. Oh, the product catalog service is not emitting logs. Then I'm going to do it with Traefik, which unfortunately does not have errors. So what I'm going to show you is how Dash0 actually applies AI to automatically discover attributes. Let me actually get the cart service because the Traefik people have done way too good a job of actually already providing structured logs. Look here. You see, when we look at something like this, we automatically see that there is a pattern. And here we actually extract it. This is something that Dash0 recognized and materialized the pattern in a way that you can use to query it. So for example, now I can go and group by user ID, actually this one, and then I see the breakdown. This is the kind of stuff that normally would require you to use regular expressions to figure out, either when you ingest the logs or when you query them, and with Dash0 it comes out of the box at no extra charge. After you find issues like the ones that we had with our product catalog service, you normally will want maybe to create a dashboard, maybe to create an alert. I'm going to pivot to dashboards because they're boring, they just work. What is not boring is the entirety of the pricing model of Dash0. These are all the SKUs. It's about how many spans you send, how many log records you send, how many metric data points you send, how many events in the web monitoring, how many synthetic API checks. We do not really care how big your spans are or how big your logs are or how much metadata you send. There are some fair usage policies in place, but nobody has hit them yet. The more metadata you send, the better triage becomes. There is more metadata to work with. And one of the things that I really like of Dash0, and we actually engineered, both in terms of the pricing model and the product, is that Dash0 is the best tool for you to figure out how to give less money to Dash0. For example, here we have 158 million logs. That's a bit. Let's figure out if we can reduce the bill. So I'm going to go to logging, and I'm going to group my logs by the service name. And we see here the Traefik is a bit chatty. And when we go and look at the logs, these are Nginx logs, and if you have existing pipelines to actually process those logs, it's a good idea to keep them. Or you could say, hey, I actually have tracing data, which is strictly better, so let's throw those away. I click on spam, then flag as spam. I press this button, and an ingestion rule is deployed in Dash0 so that the next logs like this that you're going to send, they're going to be discarded and you do not pay anything for it. No ingress charge, no processing charge, they're just gone from the tool and from the bill without you having to change any of the configurations of the product. Now, we also have integrations which allow you to quickly onboard to supported technologies. And of course, we have one for Traefik, which comes both with information about how to configure it, as well as a nice dashboard that you can automatically import and have an overview of how your Ingress controller is performing. This is based on the information that Traefik exposes, the logs, the metrics, the spans, and it showcases the kind of things that you can easily do the moment that your technology provider has done a good job of integrating observability. By the way, Dylan, if there are questions, feel free to throw them at me because I do not see the Q&A panel.
I see one, and this is something that during the preparation we quickly touched base. And you did not answer that question because of the time that it would require for you to answer. But now I would like to see a short summary because the question is about sampling. And Julian asks about that they sample now on the OpenTelemetry collector. And can it be done inside Dash0 or in Traefik? On Traefik side, I know that we have sampling settings, so of course you can turn it down. But you have an opinion about sampling that I would like to hear now.
I have infinite opinions about sampling. The very short answer is that right now spam filters are very binary. You throw the data away or not. And later in the year, we will start working on what we call observability pipelines, which will actually provide you an easier way of doing sampling, doing transformation of telemetry from inside Dash0. Now, when we talk about sampling itself, and that was the question that Emmanuel threw at me and I refused to answer because I wasn't in the mood of giving 5 TED Talks, there is a very opinionated discussion to be had about what is the correct sampling. Now, there are effectively 2 families of methods for sampling. One is head sampling, which is the short for probabilistic head sampling, meaning that given a trace, there is a fixed probability that all the spans of the trace will be collected or not. Probabilistic head sampling is easy. Easy is good, but it also requires you to be very mindful of the level at which you sample to still retain statistical validity in the results. Not all APIs are the same. When you use, for example, the API management of Traefik, you will always see that some APIs get slammed and other much less. You must be very careful about setting the percentages by which you sample. And for example, APIs that get like bajillion requests a second, you can sample pretty aggressively and still have a pretty good idea of how they're doing, and maybe transform those spans into a metric. For APIs that have a much lower usage, keeping more of the data is usually a good idea. There is also an entire discussion to be had about whether you can actually work with probabilistic head sampling and APIs with very low sampling levels. And that is why people pivot to the second family of sampling methods, that is tail sampling. Tail sampling is the idea that you're going to decide whether you keep a trace or not by its trace ID and whether it modulo 100 is above 50 or so. It's actually about you look at the content of the trace and then you decide whether it's worth keeping it or not. In a perfect world, tail sampling is something that everybody has available, and you can keep all the traces with errors, or you can keep all the traces with new errors and errors that occur more often. You sample a bit more, and traces that are just working, you sample even harder. But the reality is that the technology in OpenTelemetry to do that is a bit difficult the moment your traces are complicated. And complicated means 2 things. One, the data coming from the trace, the spans, come across, let's say, multiple Kubernetes clusters. And the second is your traces take a long time to complete. Why does this make it complicated? Well, because to actually make a correct decision whether you want to keep the trace or not, you need to buffer those spans. And the sampling decision has to be done centrally. So all the spans participating in a trace must end up in the same collector. And while this is easy to achieve on small installations, at scale, it's actually really, really hard. And that is where you probably are going to have a better time with probabilistic at sampling. Now, I think it was enough of an info bombing. I can go on, but maybe we go and have a look at the built-in observability of Traefik, because it deserves to be displayed.
Yeah, thank you. I think that's fine.
So what I did here, since I like Emmanuel very much, which means also that I will troll him, I made Traefik red so that it stands out. So I actually created an alert rule in Dash0 that says that if Traefik is giving spans with errors, Traefik goes red. Yeah. And why does Traefik goes red? It's not because of the failures that Traefik does. It's because it is forwarding requests that failed at some point in the trace downstream. Let's have a look at it. As you can see here, Traefik is also emitting logs, and we actually can do something really cool and start from the logs instead of traces like before, so that we can showcase how Traefik is correctly using the OpenTelemetry metadata, so adding the trace context to the logs, so that these logs are not just lines of text, they actually are associated with the spans that Traefik produces. So one button, and I actually see the trace of that log. This is pretty cool, and actually without Traefik doing a good job, it requires a significant amount of work to do on your end. Emmanuel was talking about Ingress Nginx. Ingress Nginx has OpenTelemetry support, but only for tracing. The logs, you have to go and get them from, we're talking Kubernetes, so it's the file log receiver and the collector getting logs from var node. And you need to parse those logs with the OpenTelemetry collector. You need to actually transform them with OTel to add the trace context to it. And it's actually a couple of hours of fun, especially if you're not used to this. If you're interested, we're actually publishing a series of articles about Ingress controls and OpenTelemetry support. And maybe Dylan or Benedict can put it in the chat. You will see how you actually need to do significantly more work with Ingress Nginx to have the same baseline of healthy observability that Traefik provides you literally out of the box. So one click, you are in the traces. We can go and have a look about what type of errors are forwarded by Traefik. Notice how I can actually see immediately the correlation with errors. And now that we pin that the service is Traefik, we actually go to the next most important attribute. So which version of the service it is, in this case, service. And again, we can do triage and one and done. And now we see that all the errors that are returned to the user is actually through the API recommendation. This is not Traefik's problem. How do I know? Because I can select just these and then go and look at where the arrows are coming from. And you see with these parent-child relations, I mean, I see that the arrow is going back all the way. It's not Traefik's fault. It is this is the recommendation service. So it's coming from here. There is one last thing that I wanted to talk about, and it is the importance of observability in Ingress controls. Ingress controls are effectively the linchpin of how your users consume your applications deployed on Kubernetes. They are literally the gatekeepers. Nothing gets into the cluster without the Ingress controller touching it. So if there is one thing that you should monitor really well, is the Ingress controller, because that is the one place where you can see how the requests getting into and out of the cluster are going to be perceived by the end users. That is incredibly powerful, and I'm very happy that the Traefik people take observability very seriously, as it is, in my experience, people tend not to monitor the Ingress controllers nearly as much as the pods, which is an artifact of other Ingress controllers not having been comparably easy in the past. But now, folks, it's a no-brainer. Is there any other question that I can answer before we go back to the normal presentation?
No questions at this time.
All right, then let me swap back to the beautifully designed slides. So this was the Dash0 demo. I hope you liked it. If you like what you saw with Dash0 and want to try it yourself, we have a 14 days trial, no questions asked. We built Dash0 not only to be easy to use and pleasant to look at, but also to be as useful as possible and to avoid vendor lock-in. We are not going to use proprietary data formats. Everything that goes in and out of Dash0 is open formats. You send data in OpenTelemetry, you send logs in Elastic format, in CloudWatch. You get data out using PromQL to query metrics, but also logs and traces. We have some very cool stuff with that. And dashboards, you can import and export through Persis, which is a very interesting, very dynamic community that actually wants to make an actual open source dashboarding rather than the other big one being effectively a vendor thing. The alerting model is based on Prometheus, so every single Prometheus alert rule that you have that you use today will work out of the box, and there is a lot of integrations that you can use to send it out.
If I can chime in, you write no master or PhD needed for PromQL with you, and I honestly take a huge surprise at people when they can just fluently write PromQL. It's so difficult for me to master. And how is it with you?
Oh, then thank you for asking. Then I jump right back into the demo. Give me a second. So you can query every single piece of data in Dash0 through PromQL, but you do not have to. Let's see, for example, how it feels to create an alert for Traefik. In this case, I'm seeing there is a lot of red. It's not very good. So what I will do, I will just either select only the erroneous ones and then say, hey, this is too much, and then click create check rule. This automatically creates the alert for me. I just need to set up the name and set the threshold, like tell me next time that is more than this much. Done. Your alert is done. At the end of the day, even though now we were using trace data, we actually show you how to achieve the same with PromQL. And the magic is coming from this metric. This metric is not an actual metric that was scraped from somewhere. This is not coming from the Prometheus and from the OTLP metrics that Traefik pushes into Dash0. This is calculated on the fly based on the spans that Traefik sends. You can also do other things, like, for example, duration percentiles. One click and you're done. Here comes in a different metric. This is a histogram about the duration. So how long it takes for Traefik, how much time elapses from Traefik receiving a request and emitting a response back to the client. You can do similar things, for example, with logs. I could go there and say, hey, show me how many logs are coming from Traefik. And that's a bit much. I could actually say, okay, show me how many of those are actually info logs. And here I could create an alert to say, hey, if this is sending too much data, I need to do something about it. You could also, with the same logic, create alerts where the logs give you errors. So it is very, very flexible, and it's not limited to only metrics. And given the fact, and since it is one single query language, you can actually create amazing things. You can go in PromQL mode and combine things. The other day, a customer was showing me a case where he actually was alerting on spikes in logs not matched by spikes in spans. So all of a sudden, their services were logging way more than it was expected based on the amount of requests they were serving. And this is possible because we found a way to use this one query language across the platform. Out of curiosity, Dash0 backends are written in which languages? The answer is yes. Several of them. Most of it is Go. We have some Java, some Node.js, some Rust in a few places. Dash0 is only SaaS, so we get to have fun. So Ingress controllers are usually the responsibility of platform teams and platform engineers. And together with Casper Borg-Nielsen, who's DevRel at Dash0, and probably the most beloved person in the entire Scandinavia, because every time I go with him somewhere, everybody knows him. We made a course on platformengineering.org, which is entirely free, and it will tell you a lot of what you need to know to be successful in providing a Kubernetes-based platform for your developers to be successful with. It's entirely free. Go have a look. If you like it, let us know. If you don't like it, scream at me. And this being said, this is the time for more questions, folks.
Thank you, Michele. Thank you, Emmanuel. Awesome presentation. I do have a couple questions here. Let's see. Does Traefik support Zipkin header propagation?
I will take this question. Yes, we do. Also, these are called sometimes B3 headers, and we support that. And also, not only those, but the default trace context in OpenTelemetry and X-ray and others as well. So, yeah, we support a wide variety.
Do you know where B3 comes from?
Oh, I would like to know that.
So, Zipkin actually originates in Twitter of yore. And B3 stands for Big Blue Bird.
Oh, wow. Okay, so this is it.
A little bit of extra lore.
The observability lore. Logs, here's another one. So logs can contain sensitive data. How do you handle that?
So in Traefik, you can catch it at the gateway side or the proxy side. No matter which version you are using, it's there. You can mark some log headers, for example, authorization header as sensitive. You can drop it right on the before it's outputted to logs, and also you can redact some headers. Maybe you want to see that there was an old header, but you just want to redact the sensitive data inside.
And there is also a larger answer in the how do you do that in the OpenTelemetry ecosystem? And the answer to that is the OpenTelemetry Transformation Language, OTel. Give me a second to Google something up so that I can give you a better idea of that. In the OpenTelemetry collector, so in OpenTelemetry, there is one piece of software of the many that are part of OpenTelemetry that is the most important, and that is the collector. It is the one piece of software that I said it is the last observability agent that you ever need to learn. And it is effectively a Swiss Army knife of getting telemetry from somewhere, either by receiving it, like when Traefik pushes via OTLP, logs, metrics, and spans, or, for example, by scraping Prometheus endpoints. The OpenTelemetry collector can also go and get telemetry. And you can forward it to a lot of different places. And it not only understands OTLP, but for example, there are exporters for most commercial vendors that you have heard of. And as the telemetry goes through the collector, you get to do stuff to the telemetry. One of the most common things that you want to do is actually to redact information from telemetry. And this you do with the OpenTelemetry transformation language. There is the component that you're going to use is a processor. And this processor is called the transform processor, where you can actually specify rules to go and, for example, delete data, like to drop attributes wholesale, or maybe change their values by applying some masking. It's always a great idea to have the telemetry from your applications go through an OpenTelemetry collector you control before landing in, for example, a SaaS observability tool, because that is the one place where you can apply these transformations.
Awesome. Thank you for that. Last question I have here. Is Nginx end of life? I think that's referring to what you were mentioning earlier, Emmanuel.
So not in Nginx itself. Basically, the Nginx project is still alive. It's just the Ingress Nginx that is the Ingress controller in Kubernetes, and actually many Kubernetes distributions use it as the default Ingress controller. And also some cloud providers provide it as managed service. This one, Ingress Nginx, is the one that is soon end of life. And this is mostly because Gateway API support is not coming to Ingress Nginx. And Gateway API is the future of Ingress in Kubernetes. And Traefik has support for both, and also a third one, which is a Traefik native one. But we do support regular Ingress and Kubernetes Gateway API. And also, this also provides a nice migration path to Gateway API. And the Ingress project also has a future in a new project that will come, that will have only support for Gateway API, but it's very early, only kind of initial commits made, and it has a huge backlog basically to replicate everything that existed. So starting from scratch created also a nice opportunity for experimenting with Traefik now.
And you can just drop it in, right? You keep all the CRDs, you keep all the configurations, and then you have a second Ingress control that you can route traffic to, and see which one you like best.
Yes, exactly.
Awesome. All right. That's it for the questions. Thanks again, guys.
Bye, everyone.
Thank you, Ben.